some reason they decided to put together in one unit. This is our last main topic, and it might be our most direct and most like straightforward topic. So I hope you enjoy it as much as I do. Using coordinates to compute perimeter and area. Computing perimeter and area of figures, of polygons. Before we do this, we need to figure out, well, what is perimeter and what is area? You guys have been using these for years. So what is perimeter of an object? Think about this for a moment. And tell me in the chat, what is the perimeter? Not like the number, because we don't have an object here. But if I had a rectangle or a triangle, what is the perimeter describing? From the best of your memory or your knowledge, how would you describe the perimeter of an object? Two comments. All right. I'm glad two people commented, or at least there's two comments. Does the rest of you, let's see, should be three more of you. Do you guys remember what perimeter means? Best of your memory. How would you describe it? Or if you really don't know, just tell me, I don't know. Okay, good. Nice. So I see three people, and three people referenced the outside of the object. I appreciate that. And then also someone said the size, and then someone said the shape. The perimeter is describing the distance around the object. So if we want to know perimeter of a rectangle or of a triangle, we would need to know how long are the sides, basically. So if we know those sides, we can figure out the perimeter. In this quick example here, I've got a rectangle with a height of 5 on the left and right, and then the length of it on the bottom and top is 10 each. So the perimeter would be adding up all those distances around the object. So what would this be? This would be 10 plus 5, 15, and then another 15 for a total of 30 for this rectangle. And then same idea, if we wanted to find it for a triangle, we would have to know all the side lengths of our triangle and add them all up. So if this is A, B, and C, we don't know the numbers, but we're labeling A, B, and C. The perimeter would be A plus B plus C. Now, related to perimeter is the idea of area, and this is maybe what you guys also meant by the shape. So what is area? This is a little more specific than perimeter. Any ideas? How would you describe area? How do you remember it? It's related to perimeter, but it is different. I see one idea in the chat. Thank you.
Isn't it like opposites? Because like perimeter, isn't it the outside, and then if it's opposites, wouldn't it be the inside of it? Of a
Okay.
shape?
Yeah, we'll take that. Thank you, Manaya. And Aaron also said the inside. Great, guys. Thank you both. So it is describing the inside. It's like the space inside. So perimeter is the distance around, whether no matter what shape we're dealing with, it's the distance around. Area is the space inside. So if we had our same triangle, or sorry, rectangle of 5, 10, 5, and 10, the area is telling us how much like flat space it takes up to make this rectangle. So how do we answer that? It's the space inside. It's how much flat space it takes to form that shape. How much space is inside. let's really quick review how to compute both of these now. So we kind of did a perimeter review already with our 5, 10, 5, and 10. How do we find the area of a rectangle? So we have, let's use the same one we've been using, 5 and 10. 5 and 10. So we've figured out its perimeter already by adding up all the sides. What about the area? Does anyone remember how we compute area of a rectangle? How do we describe that space inside with a number, with a value? For a real world context here, it might be like wallpaper on a wall. So if I wanted to put wallpaper up on my blue wall here behind me, how much wallpaper would I need? Do I just go to the store and wing it and hope I get enough? Or can I compute the area of my wall first so I know how much to buy? Antonio, high five to you. So Antonio said it's 5 times 10 for this example. That is correct. And if we want to say that generically and generally for all rectangles, it's the height times the base or the height times the bottom, basically. So it's side times side. We need the little side and the longer side. And that's the area. So I'm going to say it's side times side. You'll see it differently in every different math book or Edmentum or whatever, how they call that, whether it's going to be uh, the base times the height or the length times the width. It's all the same thing. We're just saying it's one side times the other side. Okay? Length times width, base times height, side times side, it's all the same. So for this example, I think it was Antonio said 5 times 10. So this would be 50. And we're dealing in some units, right? So this is like 5 inches, maybe 5 feet. Let's say it's 5 feet and 10 feet. So for the units, if we multiply those together, 5 feet times 10 feet, well, we're going to get 50 for the number. And feet times feet, we have to show that as squared because we did the unit times the unit. So this is why we say it's squared for surface areas of things, for areas of shapes. Nice, Antonio, thank you. Correct, squared. So always remember that when you're squaring, like the side times side, length times width, we're getting it in units squared. Like I have right here, 50 feet squared. Now, how about for triangles, our 3-sided shapes? This one has a formula that you might have forgotten, and that's okay. It's a little more involved than the one we just used for rectangles. So let's say we had a triangle. And let's say that we knew the bottom was 20 inches. And we also know the height of this triangle. So check this out. The height is actually a perpendicular line to one of the sides. It's not the slanted sides. It's not the diagonals on the left and right of this triangle. The height refers to the straight up from whatever you've chosen to be the bottom. So if the bottom of this triangle is this 20-inch side, and maybe this height of it is almost the same, like 18 inches, then we need to know the base. I'm going to label this, and we need to know its height and the area of it. Let's see, someone's in the chat. We're going to use that, Antonio. Antonio said width and height. So if the width that he's referencing is the base of it, the bottom that we choose as this 20, then the area of a triangle is 1/2. times the base times the height. And you can think of it as the width times the height. That's cool too. Okay, but we have to have it be the true height from top to bottom of this thing, where the 18 is. We're not interested in the slant height on the sides. We're just interested in the actual bottom, the base, and then the straight vertical from there, the height. So we can plug those numbers in and find the area of this triangle. The base was 20, the height was 18. So we're going to just multiply 20 times 18 and then divide by 2 because that times a half. So I multiplied 20 and 18 and got 360, then hit divide by 2. So it looks like the area of this triangle would be 180 inches squared. Remember, when we do areas, it's always going to be units squared. So 180 inches squared for this example. That's not because of the 18 necessarily. It's just because we multiplied base times height and divided by 2, and it came out to 180. Okay, before we start the finding perimeter and area from coordinates, any questions on these last 2 pages? Comments? Concerns? Thanks, Andrew. Okay. Let's get started. So Antonio, you as well. Thank you guys for letting me know. So we're going to be finding area and perimeter of different shapes using the rectangle idea and using the triangle idea when they don't tell us the sides, but we can measure the sides because it's on a coordinate plane. This, for example. So if our figures are on the coordinate plane, then we should be able to find the perimeter and area by first counting or computing the side lengths. So if you look at this figure I have on the screen, it doesn't tell us the sides, AB, how long is that, how long is AC, but it is telling us where it lives on the graph. So I don't even want to use the points as much as I want to just count up the units. So for example, how can we measure the side of AB using the graph? Any ideas? Can we figure out from this picture how long AB is?
By looking at the line,
Looking at the line?
the XY part.
Totally. And counting how far it is from like A to B along that line. I see this and I see it's like 4 squares long, right? Like 1, 2, 3, 4 from A to B. And then double check that each square is counting as like 1 unit. Sometimes they're counting by 5s or by 2s or something, right? So double check that. It's going from 2 at A to 6 at B. So that means AB has to be 4 units long from 2 to 6. You could think of it as subtraction. 6 is the higher number, minus 2 gives us that 4. We can do the same thing for AC. Oops, sorry, hang on. We can do the same thing for AC here. So now we want to focus on AC, and it is 3 squares long. It's up at 2, positive 2 on the Y. And then what's the lowest it goes? It goes to negative 1. And you can see visually it's 3 squares tall, right? From counting from 2 going down, 1, 2, 3. Awesome. So that means this is 3 units. It's a little trickier for BC. We can't just look at BC on this picture and count squares. It's diagonal, right? It's not using the whole number of squares to go from B to C. So we do have to use our distance formula, which has come up a couple times this year, to find BC. Need to use distance formula to find diagonals. So if you've got a diagonal on one of these types of questions, we'll have to use distance formula for that. So let's do that for BC. Distance of BC. Okay, so here's our formula. It's the square root. What is the coordinates of B and C? C is at 2, -1. And B is at 6, up 2. So those are x's and y's. We're going to use those in our formula. So the distance formula generically is this. It's x minus the other x squared plus y minus the other y squared. And we have to take the square root of the whole thing when we're done with the inside. So let's plug in our x's and y's, simplify, and we'll have BC. And then we could find the perimeter. So x minus x, 2 minus 6. Y minus y. Do it in the same order that you started your x's. So since I started with the 2 from 2, -1, I'm going to start my y's with the -1. So -1 minus 2 from 6, 2. So these are the two y's together being subtracted. Now, since we're using this formula with lots of steps, make sure to do PEMDAS, meaning simplify the most complicated parts first, and then work your way towards the end. So start with the parentheses, inside the parentheses, then do the exponents, then any multiplying or dividing, and then any adding or subtracting. So this is our order of doing simplifying for any math problems, PEMDAS. So inside the parentheses, we're going to clean those up and then square them. So 2 minus 6 is -4. -1 minus 2, they're both negative, so that's going to stack up to -3. Now we've got to square these guys. So -4 times itself is +16. Remember, negative times a negative, or negative squared, is always going to be positive. So this gives us 16 plus 9. So we add those, and what is that? 25? Double check me. Now we take the square root, plane 5. So that means the distance from B to C, the length of that side is 5 units. So now it's just as simple as adding up the sides to find the perimeter. So I'm going to, since I'm running out of space here, we'll put our answers for this at the very top of the screen. So the perimeter is the 4 plus the 3 plus the 5. What is that? 12? 12 units for perimeter. Now, how about area? We have to have the base and then we have to have the height. This triangle is positioned in such a way that like the bottom of the screen, the bottom of the triangle right here, it isn't flat. So we're going to pick a side to be our bottom side, even if that's kind of rotating the triangle. Okay. So you have to be flexible. If the triangle is oriented in a weird way, make the base or the bottom any of the sides that's best for you. When I look at this, let me change my color to purple. Since we have a perpendicular right here, the side of 4 and the side of 3 are perpendicular because they're on the straight up and straight left and right lines, the vertical and horizontals. Let's make one of those the base and the other one the height. Let's make the 3 our base, and this 4 units is height. If we were to rotate this guy, it would work out as 3 is our bottom or base, 4 can be our height. So area is 1/2 times base times height. Three times 4 divided by 2. Six units squared. A little detective work to find the side that was diagonal. We had to have that for perimeter. And then we had to be flexible and adjust our triangle to be like rotated basically to make our base this side of 3. It doesn't make sense to have this like line here be our base because it's not flat. It's not sitting on that. And if we were to rotate the long side down, the BC side down, then we've got to figure out, well, how long is this right here to be our height? And that looks really confusing. Well, why not use the sides that were given because it was given to us with a perpendicular in there already. So that's why I chose 4 to be height, 3 to be base. All right, before we move on, let's see thumbs. Self-assess. How are you guys feeling about finding area and perimeter from this triangle that we just did? So either in the chat or with your camera, show me your feedback on how you're feeling so far. Antonio, thank you. And Andrew, thank you. I just want to see where you're at. I appreciate if it's thumbs up, but really, honestly, if it's not, I need to know that too. I just need to know where you guys are
I
at.
think I'm in between.
In between, Manaya? Okay. Thank you.
I'm doing pretty good.
Maria Celeste, thank you. And then that was Aaron. Thanks. Keegan. Okay. So everything you'll see in this mastery test is basically like we just did. Things will get a little different when we have to kind of chop up or like partition our picture, our figure into triangles and rectangles if it isn't already. Let's do one more like this example, and then we'll look at a more complex one. Okay, I'm going to put this up here. Find the area and the perimeter. Okay, step 1, let's try to measure all the sides. This time, it looks like only one of the sides of the triangle is flat, either up or down. So we're only going to be able to measure one side, AC, really fast. And it looks like we'll have to use distance formula to find AB diagonal and BC diagonal. Here we go. Let's first find AC. How long is that? I'm not going to say it. This time I want you guys, assuming you can see this picture, tell me in the chat, how long is AC? Count those units up.
Is it 8?
Maybe. Thanks for your vote. Let's see what the whole group is saying. See, 2 of you have answered, and then Manaya said verbally. How are they finding this? How are they trying this? They're just looking at first point A, last point C, and we're counting basically how many squares it takes to get there, how many units it takes to get there. Awesome. Aaron and Antonio and Manaya. Okay, thank you 3 for, and here's some more. Keegan and Maria. Woo! Yeah, totally. And you all did find who answered 8. You all who answered said the same thing. So it is 8. Good job. 1, 2, 3, 4, 5, 6, 7, 8. So AC, that's our fast one. It's 8 units. Legit. Now we have to find AB and BC. So we'll have to use the distance formula for those. I'm going to label AC is 8. Okay, so here we go. Let's do our distance formula as quick as we can, because it is going to be I think the longest part of this whole question. Probably for all these questions, it'll be the distance formula. So for AB, let's start with that guy. All right, first we have to locate the points. It's always X, then Y when we list our point. So A for its X is over -3 down 2, so -2. B is 2, 2, over 2 up 2. Let's go ahead and label C while we're at it. It's at 5 over, so 5 for X, down 2 for Y. All right, but we're going to use AB for this. Okay, formula, X minus X and Y minus Y is what's in those parentheses. So let's start with A minus B. So -3 minus 2. That's X minus X. All right, Y minus Y will be -2 minus 2. It's always X minus X. It's a minus between them. That's where this is coming from, the minus sign. Let's start simplifying. First parentheses, -3 minus 2. Practice combining those negatives. Go ahead and tell me in the chat, what is -3 minus 2? Try that out. -3 minus 2. You're down $3. You go down $2 more. How down are you? I need to see you guys practicing these. There's 2 answers or 2 comments so far. 3, awesome. Keep going. Should hear from 8 of you. I want to see you guys try this out. -3 minus 2. If you've already answered, go ahead and move on. Try to do the Y minus Y. All right, there's 4 comments. 5. High five, folks. Keep going. There's 3 more of you. -3 minus 2. Legit. I see Aaron, Antonio, Keegan, Delaney, Manaya, and Maria. Oh, love it, guys. Thank you for trying that. Yes. -3, go down 2 more. We're at negative 5. Hopefully you've moved on and tried y minus y. So that's negative 2 minus 2 for a negative 4. Okay, we're going to square whatever we have in those parentheses. So now the negatives kind of go away. 5 squared, or negative 5 squared, would be a positive 25. 4 squared is a 16. Add. And it looks like it's 41. Now, if you try 41 in your calculator for the square root, you're going to get a long decimal. In Edmentum, it's either going to tell you to round to a certain amount or to leave it as a whole, to leave it as a radical, meaning leave it in a square root box like this. So I'm going to show both for our picture. We found it. It's root 41 as a clean answer. But how do you measure that? I have no idea how big that is. So to measure it, we're going to actually do the square root. So 41 square root is 6.4. So it's about 6.4. It's not a whole number. Most triangles won't have all whole number sides. Andrew, thank you also for answering that last question. So now we're going to do the same process for BC. We got to find how long is BC. Set it up, x minus x squared plus y minus y squared, and don't forget the whole thing has a square root box over it for the very end. So now x minus x, 2 minus 5. Then 2 minus negative 2 for y minus y. 2 minus negative 2. Two minus 5 gives us 3. Okay, 2 minus negative 2. This is tricky. Let's see what's in the chat. Thanks, Antonio. Very good. Oh, yeah, negative 3. Yeah, teacher's wrong. 2 minus 5 is negative 3. Thank you. Now 2 minus negative 2. Remember, minus a negative, that rule kicks in and it becomes plus. Minus a negative cancels. We're doing the opposite of a negative is what that means. So it becomes plus plus and we get 4. Okay, now we square. So 9 plus 16. And that comes out to, we saw this last one, same as the last time. It's 25, which is a whole number, which is 5. So it looks like BC is 5 units. Cool. So we only had one funky answer, an irrational number, root 41, 6.4. And then we had 5 and we had 8. So now we've got our sides. So how are we going to show the perimeter? Let's do that at the very top of the screen. Remember, the perimeter is just adding, but if we have this square root of 41, how are we going to show that? Square root 41 plus 5 plus 8. Well, we can add the 5 and 8 easily, right? So do those. 13. And there's our answer. This is the precise answer for the perimeter. 13 plus root 41. We would want to leave it that way as a precise answer. And if we wanted to do the rounding, if we used 6.4, then we could plug that in for the root 41. And what is that? 19.4. So pay attention to what Edmentum asks for. If it's asking you to type in an answer, it will tell you either to round to a certain decimal place, like I rounded to the first place, the 10th place. So this is when it's rounded, and then above that we've got it precise. But we can't combine root 41 with 13. We can't add those, so we leave it as just a sum, 13 plus the root. Okay, now area I think will actually be pretty fast this time. Remember, the area, we need base and we need height, like the true vertical height from the base. So the way this triangle is oriented, it might look like the side of 5 is perpendicular to the side of root 41, and maybe it is, but without finding the slopes of those lines, we can't know for sure. We do, however, have one side that's already on the horizontal, so use that to your advantage. Notice that AC, it's acting like a base already, like a true base, right? It's on the bottom. And we can measure it. It's 8. Super easy. So the height, we can count down from B straight down for its height. Because we know that horizontals and verticals are perpendicular, and that'll give us the height. So our base will be 8, and the height will be 1, 2, 3, 4. Area formula, 1/2 times base times height. One half times 8 times 4. So multiply the base and height. That's the easy part to do first. And then divide it by 2. That's the timesing it by 1/2. We're merely dividing it by 2. 16 units squared. And that's it. We found the area and the perimeter. So now let's look at a more complex example where it's not just a simple triangle, where we have to do distance formula to find those diagonal sides. What if it's a mixture of shapes, like this one? Notice how they made a line for us from B to D. So that helps us see that this whole gray shape is a mix between a rectangle here and then a triangle next to it. So we're going to find the perimeter by adding up all the outsides. We don't need to find, we're not going to add in BD because BD is not on the outside of the whole gray figure. Let's start labeling it, and then we'll find the area and the perimeter. So AE looks like that is 6 units. AB is 2. ED down here, that's 2 units. And then we've got 2 diagonals that we'll have to find. So BC and DC. Now you might notice that those are the same mirror images of each other. For instance, BC is going down 3 squares from B to C, and then over 4, and then DC is going up 3 over 4. So they don't have the same slope, but they are going to be the same length. So if we just find BC, that'll match DC because they're like going the same amount of squares down and over or up and over. So let's find the length of BC. Okay, B is at 2 up 6. So its point is 2, 6, and C is 6, 3. Remember, it's always the X and then the Y. X first, then Y. All right, start setting this up. X minus X squared, Y minus Y squared. 2 minus 6 6 minus 3. That's x minus x, y minus y. Simplify the insides of the parentheses first. So 2 minus 6 is negative 4. 6 minus 3 is a positive 3. Remember when we square it at this stage? The negatives go away because negative times a negative. So we've got 16 and we've got 9. They're giving us a lot of the same triangle, the same right triangle. So 16 plus 9 is 25, and that does come out to a nice clean 5. So that means BC is 5 units and DC is 5 units. Cool. Now we can find the perimeter. Add up all the outside lengths, and that'll give you perimeter. Go ahead and try that. I've labeled them. Tell me in the chat what the perimeter is of this, please. Perimeter is adding up all the sides. The outsides, right? We don't need to find this inside BD for the perimeter. We only need the outside lengths or distances. I see one comment in the chat. Someone's finished. Someone said 20. Aaron, thank you for doing that and for sharing it. How did she find that? She added up all the outsides. So start anywhere you like. Let's start at the 6 plus 2 plus 5 plus 5 plus 2. Make sure not to double any up that you already counted or used. And yeah, that comes out to 20. 6 plus 4, 10, and 5 plus 5 is 10 for a total of 20. All right, area. Now this time we have to find the area of the whole figure. Do it in chunks. We can figure out just the area of the rectangle, and then we can figure out just the area of the triangle that we see, and we can add those two areas together. Awesome. Delaney, good job on that perimeter. Thank you. So let's try the area. So I think of this as the area of the sections, and we can figure out each individual section and then add them together. Area of the rectangle plus the area of the triangle. Now, the triangle, you're going to have to rotate that in your mind and make one of the sides of it the base. Always use the verticals and the horizontals to your advantage. So when I look at this triangle, a good base for it would be side BD. Why? Because it is going up and down vertically, and we can easily count those. In fact, we already have it. It's 6. So the base is 6. The height is the perpendicular going from the base up to the other vertex, C. So that's 1, 2, 3, 4. So the height here is 4. So let's set up both here. So on the left of my screen, area of the rectangle is just the side of the rectangle times the other side. So 2 times 6 units. And the triangle is 1/2 times the base. The base of our triangle is the 6th side times the height, 4. And then we'll add both separately up. So 2 times 6 is 12. 6 times 4 is 24. Divided in half is another 12. So they both separately came out to 12. Add those guys together, and it's 24 units squared. All right, it's almost time to go. We'll do one more together, and then we'll let you go for today. The homework is going to be to do this mastery test. It's called Computing Perimeter and Area, using coordinates to compute perimeter and area. Okay. Now this example, I wanted to make sure to do one of these with you because they don't actually tell us the real units. They're doing it generically with A's and B's. So how can we do this? Antonio, nice, good job. Okay, so this question, I did take it from Edmentum. It's not asking for the area, thank goodness, just the perimeter. So for the perimeter, remember, we need all the side lengths. So we're going to have to find the length from one of these sides. Technically, we need all four, right? But these are all the same distance because of the way they've built this. Each line, each outside line is like down 2 and over 3 or up 2 and over 3. So they're all the same length, which is good. So we have to use the A's and B's and the distances between those to try to figure out the length of those sides. Okay. So let's use the distance formula to find, I'm going to call this point number 1, not letters because they're using the A's and B's already. And then this will be point number 2. So let's use point 1 and point 2 in the distance formula to figure out how long is the segment between 1 and 2. Same formula, but this time the points are generic, general, A's and B's. They're not telling us that that's actually 3 or 2, okay? Squares up. We don't know. That they're just, it could be 145 for all we know because A and B are not defined. So, but we're going to use our formula the same way we've been using it. Okay, I'm going to label. So point number 1, the x is 0 and the y is b. Point number 2, the x is a and the y is 0. So x minus x, 0 minus a. Y minus y is b minus 0. Okay, so 0 minus a, well, that's going to be negative a. We don't know what a is, but it's being subtracted from 0, so negative a. B minus 0 is just b. Square. A squared plus b squared. And that is the length of point 1 to point 2. It's the square root of a squared plus b squared. And that's the best we can do because a and b are different values, or at least they could be, so we can't add them together. Nor can we figure out what that value is until we have numbers for them. So to find the perimeter, we now know the length of each one of these sides is square root of a squared plus b squared. So if we add up 4 of these special square roots, even though we don't know the a and b, if we add up all 4, I'm going to put it over here. we can count up, well, we've got 4 of the exact same thing. So the perimeter is 4 times square root a squared plus b squared. You might get this problem, or you might get another one that's similar to it, where they don't define the units, or like the units, and they leave them as generic A's, B's, or something like that. If you use the distance formula, we can still write the distance in terms of A and B, like we did here. All right, we've still got like 5 minutes. Any questions on any of the examples from today, please? Nope. All right. Awesome. Well, I've got you guys down. You're free to go for today. We're going to do a unit activity